Okay, question C of question 5. What language is recognized by the following finite state automaton? Describe the language in English and give a regular expression defining the language. I find doing the regular expressions first easier and then the language in English afterwards easier. I'm going to do it that way. So let's see. So it can't start with so what happens if I go to Q2? It looks like Q2 is a trap state. Once I'm in the bin, I sort of stay in the bin forever, right? So it looks like don't take any edge that goes to Q2. So what can I do? It's got to have an A. And then to get to Q1, it's got to have another A. And then I can read another 2 A's or another 4 A's or evenly many A's afterwards, right? So it looks like A, and then as many sets of 2 A's as you want. And then you got to go to Q5, so I've got to read a B. And then I've got to read another B. And then once I'm in Q4, A's are bad, but double B's are okay, because you go B, 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 B. So it looks like double B's are okay. There you go. So there's the regular expression. So what the hell is this thing, really? So it looks like evenly many A's, but not none of them, followed by evenly many B's, but not none of them. Because 0 is an even number, right? So we've got to exclude 0. So evenly many A's, but not 0, followed by evenly many B's, but not 0. There you go, that feels like a pretty legit description in English of what the language is. Question 5D. Consider the statement, for all W and sigma star, N star Q2 W is Q2. Express this property in English. Looks like Q2 is a trap state, right? Because basically saying from Q2, read any string back to Q2. So that is, what does it mean to be trap state? So it means reading any string in Q2 never leaves Q2. Why might that be relevant? I'll tell you why it'll be relevant. Because this is a useful property for proving what the language of this DFA actually is. So I would say relevant as it's a useful lemma for proving the language of the automata. Proving the language, the machine, the automaton recognizes. Cool, there we go. What's next? For the finite state automaton above, prove that for every natural number n, if you're in Q1, which is this state here, and you read double A's n many times over, AA, 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 you're back to Q1. Sure, that feels pretty true. And then hence, I'll worry about that in a moment. So, okay, so we want to prove for all natural numbers, n star Q1 AAN equals Q1. Okay, proof. So proof by induction. So I better state that. So we're doing proof by induction. What's my base case going to be? My base case for the natural numbers is when n is equal to 0. Not when n is equal to 1. I don't care what math 1005 says. The first natural number is 0. Alright, so we've got to prove n star Q1 AA0 equals Q1. Okay, so here's the proof. N star Q1 AA0 is equal to n star Q1 0 many copies of AA. Well, that's just epsilon, right? By definition of AA0. Well, if I'm in Q1 and I read nothing, I stay in Q1. And that's by the definition of n star. Okay, cool. Now I can prove the step case. So for the step case, I assume it's true for some n, so I assume n star q1 double a to the n equals q1. And then I got to prove it's true for n plus 1. So prove n star q1 double a to the n plus 1 equals q1. Okay, here's the proof. I'm going to use the definition. Okay, so what do we start with? So n star q1 AA n plus 1. Well, by definition, that's AA followed by n many copies of double A. So that's n star q1 AA and then n more copies of double A. By definition of double A to the n plus 1. If I'm in q1 and I read A, I go to q3. Okay? So q3 A double A to the n by, I don't know, by DFA, I guess, by definition of the DFA. If I'm in q3 and I read A, I go straight back to q1. So that gobbles up this A. And then by my inductive hypothesis, so this is by DFA again, by my inductive hypothesis, I assume this was q1 by IH. I guess I better label this rule IH. Cool, there we go. So, therefore, statement holds by induction. Holds by induction, blah, 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 blah. Okay, we're not done yet, and hence or otherwise conclude this property here. So we also got to prove for all natural numbers, n star q naught double a to the n plus 1 equals q1. Well, thankfully we don't have to do another induction proof. I can just use the previous property to help me. So n star, okay, so here's the proof. You break off the first set of double A's. So we have q naught, a, and then the rest of the A's. If I'm in q naught and I read A, I go to q3. A, then double A to the n. And if I'm in q3, I read another A, I go to q1. Double A to the n. So what this is by definition of double A to the n plus 1. This is by the DFA. This is also by the DFA. And then we know this is q1 because I proved that by induction earlier. So by above. Cool, there we go. Both properties hold.